Welcome back. I hope you're ready for some serious math action. We're at lesson 17, rounding and estimating. Your objective is to round numbers to a given place value. Let's go ahead and get started with the fun fact of the day, which is that a toothpick is the object that is often most choked on by Americans. Okay, so keep those toothpicks out of your mouth, boys and girls. Alright, and example 1 says round 1,481,362 to the nearest 100,000. First thing I like to do is to go ahead and rewrite the number. Okay, 1,481,362. Alright, so I want to round to the nearest 100,000. Now, I need to know what place value that is, and I like to underline what place value I'm looking at, which one they're asking me for. Okay, now we read place values from right to left, which I know is backwards from what we usually do. We're going to start over here and read till we get to the 100,000s. Well, this is ones, tens, hundreds, thousands, 10,000s, 100,000s is right here. I like to underline that spot. Okay, so I'm looking at that 4, and I need to decide, do I round it up to a 5 or do I keep it as a 4? Alright, well, my general rule of thumb is if we are at, let's see, in decimal terms, if I'm at a 5 or higher, okay, we round up. And if I'm 4 or lower in decimals, we don't round down. That's tough to say. We keep it the same. Okay, we keep the digit the same. Okay, now I always look at the place to the right of the number, so I usually like to circle that one actually. This is the number that's going to tell me whether I need to round that 4 up or to keep it the same. Okay, well 8 is higher than 5, so that means I'm going to round the 4 up. So I keep every other digit before that. Okay, so my new number, I'm going to have a 1, and the 4 rounds up to 5. And then I take every other digit after and fill in zeros. So the 8 and the 1 and the 3 and the 6 and the 2 all become zeros. So again, we keep the digits in front the same. We round our place value, and then everything else gets filled in with zeros. Go ahead and do this one with decimal places. This is 3.14159. That's an approximation of pi. Okay, that's the first few digits of pi there. So again, I'm going to rewrite the number, 3.14159. It says to round it to 2 decimal places. Well, 2 decimal places just means 2 spots after the decimal, so that's right here. And again, I always look to the right when I'm rounding. Well, that number 1 is 4 or less, so that means I'm going to keep my 4 the same. Okay? Well, in this case, remember I rewrite the digits that are in front of that number and I keep it the same. So the 3 and the point and the 1 stay the same. Okay, the 4 is going to stay the same. And in the decimal places, I don't need to fill in the zeros afterwards. It specifically said I want 2 decimal places. So I've got my 2 decimal places, and I am done. Right there, 3.14. Alright, example 3 says to round each number to the nearest whole number. Alright, so here's my fraction, 13 and 5/12. Okay, and a whole number just means a number that's not a fraction. Okay, so I need to round off 13 and 5/12 to either 13, the number lower than that, or 14, the number higher than that. And the rule with fractions is if that it's a half or higher, we round up. And if it's less than half, we keep it the same. Okay, so I'm looking, again, I want to round to the nearest whole number here, so I want to round this to the nearest whole number, which means I'm looking at this number, figure out what's that tell me to do. Well, 5/12 is less than a half, so I'm going to keep these digits the same. So I'm just going to rewrite this as 13. That's the nearest whole number. Okay, now part B. And we got 13.512. round to the nearest whole number. That again means right here. Okay, so I'm looking at this digit for rounding purposes. Well, the 5 tells me to round this 3 up. Okay, we just went on that in the last slide. So that's going to tell me to round up. So I keep the 1 the same. I round the 3 up to 4. And there's my answer to the nearest whole number. Again, quick reviews of rounding there. Now, we use rounding when we want to estimate. So when we want to get an approximation, we want to kind of guess. Okay, get an about sort of answer. So this one says, Ivan wants to tile the floor of a kitchen that is 12 feet long and 8 feet wide. The installed tile is $7.89 per square foot. Ivan calculates that the cost to tile the floor is this much, and we want to know, is his calculation reasonable? So we want to get an about amount. Okay, we want to see if we actually solve this out, is our answer going to be close to this? If it is, his answer is reasonable. Okay, if not, his answer is not reasonable. Well, it says he's going to tile the floor of a kitchen that's 12 feet wide and 8 feet long. So there's 12 feet long and 8 feet wide. So here's a diagram. And the installed tile is $7.89 per square foot. Okay, well, square foot means I got to find the area of this. Remember when we tile a floor, we're finding tiles in here. So we have to first find the area of this. Okay, so we got to find the area of the shape, which is 12 feet times 8 feet. Well, 12 times 8, that's 96. And feet times feet is feet squared. Alright, so the area is 96 feet squared. And it costs $7.89 per every one of those. Okay, $7.89 per every one of those. And we're just trying to figure out about how much we're going to have to pay. Well, I'm going to go ahead and round this and say that's about 100 feet squared that we had to pay for. And if it's $7.89 per square foot, that's about $8 every square foot. Okay, so we have about 100 feet squared of area. It's going to cost us about $8 every square foot. So we're going to multiply those two things to figure out the total cost. And 100 times 8 is about $800 is what our estimation is. It's going to cost about $800. He only came up with $315.60. So, no, it's not reasonable. And it's not reasonable. It's not reasonable because his calculation is way too low. Okay? His calculation was way less than our estimate was. Right? So again, that's one of the good things about estimating and rounding, is that it lets you see if you're in the ballpark, so to speak, on your guesses, okay, on your calculations. And the last one here says, Richard is paid $11.85 per hour. About how much money does he earn in a year, 52 weeks, if he works 40 hours per week? Okay, well, we know he's paid $11.85 per hour. So he gets about $12 every hour he works. Okay, and it says that he's going to work a year, which is 52 weeks. So he's going to work about 50 weeks, and he works 40 hours every week. So in every one of those 50 weeks, he works 40 hours. Okay, well, we can figure out how many hours he's going to work if he works 40 hours every week times 50 weeks. Okay, we would multiply those together. So he's going to work about 2,000 hours total. And he gets $12 every single hour about. So if he gets about $12 every hour, and he's going to work about 2,000 hours, we just multiply those together to figure out the total money he'll get. Well, 12 times 2 is 24. We fill in the 3 zeros. So he's going to get about $24,000 in that year. Okay? So if he works 40 hours every single week, which is pretty standard, and he works every week that much, he's going to get about $24,000. And that is your lesson on rounding and estimating. Thanks for listening. Make sure you ask any questions if you have them. And of course, as always, happy homeworking.